In this chapter, we're going to be discussing how to write chemical equations, how to balance chemical equations, and then if we're given the reactants of a reaction, how to predict what the products of that reaction are going to be using 5 different reaction types. This video specifically will be talking about how to write and balance a chemical equation, so what it will look like, what the different things are you'll see near a reaction arrow, what the different states of matter are, and then how to go and balance an equation and make sure that you have the same amount of everything on each side. You are going to need a notebook and you're going to need something to write with. Once you have all those ready, let's go. Okay, so the general form of any chemical equation is that reactants on the left and they're going to produce products on the right. You have an arrow separating the reactants and the products. In this case, the arrow is a single direction arrow because the reaction will only go one way. If we ever have a reaction that is reversible, the arrow will point in both directions. So the example equation that I have down here is that phosphoric acid, H3PO4, reacts with barium hydroxide, and that will form barium phosphate and water. This equation is balanced because it has the same number of every atom on every side, right? So each side has the same number of H's, it has the same number of phosphorus, the same number of oxygen, and so on and so forth. Right? So all equations have to be balanced because balancing an equation causes it to obey the law of conservation of mass. Everything you put into a reaction on an atom-to-atom basis, you have to get out of the reaction same number of atoms. And the way that we balance is we put numbers in front. We use coefficients. Coefficients in chemistry work the same exact way that they do in your algebra class, being that they multiply everything. Right? So here, coefficients and subscripts will multiply. If you have multiple subscripts, they will multiply each other, and then that will get multiplied by any coefficient that you have. So for example, if we have 3 BaOH in parentheses 2, that means that the 3 multiplies the number of barium atoms, giving them 3. The 3 and the 2 multiply the number of oxygen atoms, giving you 6. And they also multiply the number of hydrogen atoms, giving you 6. So that's how we're kind of going to go through and balance, and we're going to change those coefficients in front to make sure everything works itself out and you have the same mass on each side. Now, some other things that you'll see in the equation is you will see the different states of matter written for each substance. S means that it's a solid. It's what we call a precipitate. L is a liquid. You won't see that very often. You'll usually see it with water. G is obviously a gas. And AQ means that the substance is aqueous or dissolved in water. Also, above the reaction arrow and below the reaction arrow, you'll generally see any special conditions the reaction needs to take place at. So say, for example, you need to heat the reaction up to boiling or 100 C. You'd see 100 C written over the arrow to tell you that you have to heat it up that high. You'll also see catalysts written above the arrow. And remember from your biology last year, a catalyst is any substance that, while not consumed in the reaction, will speed up the reaction. Right, so you'll see those things written above and below the arrow as well. When it comes to balancing, there are lots of different ways you can go about balancing equations. None of them are really right or wrong. It just may be easier or more difficult for the equation. The way that I'm going to present is I'm going to present what's called the MIND method. MIND means that we start off by balancing any metals in the equation first. Then we balance ion groups. Ion groups are things like sulfate and nitrate and hydroxide. You don't have to do the ion group step if you don't want to. You can just split everything out by elements. Then you do all the nonmetals after you do that. But any element that's naturally diatomic, so any of your 7 have no fear of ice cold beer, you do those last. Especially oxygen and hydrogen. The reason for that, oxygen and hydrogen in a chemical equation have this weird tendency of being everywhere in the equation. Right? So trying to balance oxygen, for example, from 4 different things in an equation simultaneously is usually extremely difficult. So what we do is we save it to last, and we just hope that at the end it either works itself out completely and we don't have to do anything, or the solution will be very apparent and easy to implement. So let's try a balance here. Our reaction, we have the equation aluminum nitrate plus sodium phosphate produces aluminum phosphate and sodium nitrate. When I give you chemical formulas, those chemical formulas are already correctly drop and swapped. So what we'll start off with is we'll start off with our metals. First metal is aluminum. If we look on the left-hand side of the equation, I have one aluminum atom. The subscript 3 doesn't count for aluminum because it's not after the aluminum. Only the one subscript on it counts, so there's only one Al on the left. On the right, we have also one Al. So one on the left, one on the right, they're balanced. Our next metal is sodium. We have 3 sodium atoms on the left, 3 Na, but we only have one on the right. The way that we balance the sodium is we change the coefficient. You cannot ever change a subscript in a chemical reaction, only the coefficients. So because I need 3 sodium atoms on the right-hand side of the equation, I'm going to put in a coefficient 3 in front of the sodium nitrate. So now I have 3 times 1, which is 3 Na. Our next element, we'll look at Ns. On the left-hand side in the aluminum nitrate, I have 3 nitrogen atoms. The one subscript inside the parenthesis times the 3 outside. On the right-hand side, I also have 3 nitrogens. The one subscript on the nitrogen times the coefficient of 3. Okay, so far, aluminum's balanced, 1 on each side. Na is balanced, 3 on each side. Nitrogen is balanced, 3 on each side. I'll save oxygen for last because it looks very difficult to do. We'll do phosphorus next. I have 1 phosphorus on the left. I have 1 phosphorus on the right, so that's balanced. So because everything except for oxygen right now is balanced, hopefully it just all worked out. So let's find out. On the left-hand side, I have a subscript of 3 times 3 for the nitrate. That gives me 9. I have 4 more from the sodium phosphate. 9 plus 4 is 13 oxygen. On the right-hand side, I have 4 from the aluminum phosphate plus 3 times 3, right, the 3 coefficient times the 3 subscript gives me 9 on the right for a total of 13 oxygens on the right. So oxygen is balanced at 13 on the left, 13 on the right. Our equation is balanced. We'll just make sure our coefficients are at the lowest ratio. We've got 1, 1, 1, 3. That's definitely the lowest ratio. So we're done. That's the balanced equation for aluminum nitrate plus sodium phosphate yields aluminum phosphate and sodium nitrate. We're going to get a chance to practice plenty of these. Again, the more you do these, the better at these you get. And I will see you guys next time when we talk about different reaction patterns.